All right, this is the second day for the Pythagorean Theorem. Just a little sign in. The tacos theme will make sense later. Okay, so as we saw at the end of yesterday, we talked about why the Pythagorean Theorem is important, which it's going to be all of the above here. It helps show that irrational numbers exist. So irrational numbers, to review from 6th or 7th grade, they're numbers that cannot be written as fractions. So when we're taking square roots, they happen all the time, except when basically they're perfect square roots. So the square root of 81 equals 9 exactly. That is rational. That's a whole number actually, but that's still rational. Irrational would be like the square root of 80, where we don't have an exact answer. We know it's like 8.9 something, 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 something. It goes on forever. That was discovered partly through the Pythagorean theorem. It helps us find missing side lengths for right triangles. Yes, it does. And proving it requires logical, abstract, and sometimes creative thinking. So all of the above there. Okay, so Alma is going to walk through the park from point A to point B. We can draw on here. What distance will she walk? We see these labels here. So this is a Pythagorean theorem, right triangle problem. So you're just going to do 200 squared plus 200 squared, which is 80,000. And then you're going to take the square root of that answer. So you could actually write it as like one expression if you wanted. I would probably write it out in at least 2 steps using paper. But the square root of 200 squared plus 200 squared, this leg's square plus this leg's square equals the hypotenuse squared, which we take the square root, and we get 282.843-ish. That is irrational. But nicely done here. We actually see the animation. Isn't that cool? Here's another one. I was wondering if that took our answer from the previous or if that was just set to be 282.84. But again, that's what we got, so it doesn't matter. Alma walks 5 feet per second. How long will it take her? So if it's that many feet divided by 5 feet per second, you don't need to label all of it. I was trying to label to make it more specific, but it doesn't really matter. It's just making it look confusing. You divide it. So 282.84 divided by 5 equals about 56.568 seconds. Again, this was not exact, so we don't have the exact answer, but we can round it. We have a pretty good idea. And again, the nice animation there. All right, here's our tacos. Imagine you are on the beach and you are getting hungry. Use the sketch tool to show the route you would take to the taco truck. So, I know the route I would take. I'm assuming you wouldn't stroll around here and just dilly-dally and, you're going to play in the water for a little bit, even though you need these tacos, and then you're going to come and knock down all these umbrellas, and then you're going to walk over. No, that's not how it's going to go down. You're going to go straight, a beeline, as they call it, for the taco truck. And they kind of even gave you points here and there to set it up, so that's definitely what we're going for. Explain the reasoning behind your sketch. Good enough reason. Okay, so Daniel and Brandon choose different routes to get to the taco truck. Maybe the beach is hot and Daniel's just like, I need to get to this boardwalk. Who do you think will reach the taco truck first? Who do you think? They'll arrive at the same time? Brandon, Daniel, what information would help you know for sure? I want to know their speeds. What else would I want to know? What's the temperature? When's the last time I ate? But really, the only important thing is their speeds, probably. Speeds and like distances. I'm assuming they're going to give us distances. All right, so their speed on the boardwalk. Ooh, so we've got two different speeds going. Their speed on the boardwalk is 5 feet per second. Their speed on the sand is 3 feet per second. And we have the dimensions that we wanted. Determine the amount of time it will take for Daniel and for Brandon to get to the taco truck. Yeah, I think paper and pencil is going to be necessary. All right, so Brandon's easy. Brandon's a straight shot, all sand, no problem. Oh, but we don't even know how far it is. I guess we're going to use the Pythagorean Theorem. So 489 is the one leg. The other leg's 327.6. So we're going to do the Pythagorean Theorem with those. So is this a... Here's a calculator. I'll move my face there. 489.6 squared. Thank you. It's got the good math type. 327.6 squared. It wasn't 0.6. Sorry, I feel like my mind is out of it right now. So there's errors. Let me know. So that's that. And then we're taking the square root. Can I do square root? Yeah. I can take the square root of that whole thing. And you should pause these and do them yourself before I give you answers. But that's 489. I'm going to at least write that down. Huh, that's weird. Oh, it's because I didn't square it. I was thinking it was weird because it wasn't much more than my one distance. 588.594. I'll go to 3 decimals. Does it tell me how many decimals to go to? No, it does not. So that's probably good. That's the distance, remember. So that's feet. We still need to divide by 3 because that's the speed per second. So dividing it by 3, we get Daniel's time, Brandon's time. Whose time? Who's Sandman? Brandon. 196 point. How many? Let's go to 2 decimal places. Okay, Daniel's time is probably going to be more difficult. So Daniel's time we're going to have to divide into 2 parts. Maybe it's not more difficult. So we got 327.6. This is on sand again. That's the distance. Didn't have to do anything. Divided by 3. So 109.2. And it's that plus the boardwalk, which we have that distance, and we know that's 5 feet per second. Probably makes sense if we can go faster on boardwalk than sand. And kind of curious what that piece of it is, 97.8. And we're adding them together, and we get exactly 207, which that's cool. Exactly 207. Seconds. Man, I am out of it. Does that make sense? So Daniel's a little bit slower. Let's check it. Let's make sure. Oh man, this thing's so good. Was that right? I'm gonna just go through that again just because that was sick. Let's make the 196.2 Boom. Boom. Oh my God. That was pretty nice. Other routes are possible too. Some may be faster than Brandon's and Daniel's. I bet some are faster. Use the movable point to choose a route for Zoe that you think will be faster than the routes that Brandon and Daniel use. So I know that I would think any amount of angle here is going to save some time from Daniel's, but Brandon's are beeliner. But is like that faster? Is that faster? I don't know. I would think probably something like this. I'm going to safely say is faster. 42069. Wow. That's cool, Desmos. Yeah. Check it. Oh, I actually have to calculate it. Come on. I feel like a student right now. Okay, so to calculate this, we have the right triangle part. We can find that hypotenuse. So that is, bring up my calculator. That is 420 squared plus 327.6 squared. Square root of that, 532.65. That seems right. And that is this hypotenuse. That's over sand. So we're dividing that by 3 like we did. And we're adding in 69 was the distance on boardwalk. Nice. Divide by 5. 191.35. 191.35. Suck it, Brandon. Oh, the closing speed of Zoe. All right. That was good. That was faster. The goal here, we'll have multiple people have theirs, and we're going to find the actual fastest time, which this would be a pretty good. I think you could write it as like a calculus problem. I'm probably going to look at that on my own time to figure out the actual best angle. Maybe you don't even need calculus, but I'm not going to do it right now. So look at this expression that looks exactly like what we already did. Move the draggable point to show the path that matches the expression. Plus 100. So where's 100? Boom. Then explain what each part of the expression means. So you should explain it on your own, but basically the first, I'm just going to say the first fraction represents the time on sand, and the second represents the time on the boardwalk. The numerators are the distances, and the denominators are the speeds on each surface. Because one's divided by 3 because that's sand, and one's divided by 5 because that is boardwalk. So that's probably good. You can get into like the specific numbers, 327.6 and 100 are the two legs of the right triangle with the sand hypotenuse. 389 is the boardwalk distance. I already said, but yeah, something like that. That was a pretty good explanation, if I do say so myself. When we saw Daniel versus Brandon, Brandon won. Determine the speed on the boardwalk. That would make Daniel and Brandon arrive at the same time. Sick question. Okay, so now we want them to arrive at the same time, and we want to change this boardwalk speed. So as is, with 5 feet per second on boardwalk, let's try it. We saw that Brandon's gonna crush him. Not actually that bad. So obviously, if we adjust this time, if we made it like 4, probably we'll see something different. So 4, Brandon just destroys. Oh, let's go like 10 feet per second on boardwalk. Like this is just a like at the airport where you've got the little what do you call them? The walkway that just automatically kind of moves you forward. So this is just gonna like super accelerate Daniel. It's pretty cool, right? I think it's cool. 100. I'm enjoying this. Sorry. I'm I like the slow mo because it like slow mo's like when he gets to a certain like time behind when he's gonna finish, and then it's just like boom. He's like the Flash on Boardwalk. It's like the Flash's vulnerability is he just can't do anything on sand, and then on Boardwalk he's the superhero again. Okay, so we've put off solving this for long enough. Did we have the expressions here? I want to write the expression for each so that then we can think about what we need to solve because we're trying to set these equal. Okay, so remember, Daniel's expression was this is the guy who spent some time on the boardwalk. 327.6 divided by 3. That's not changing. Plus 489 divided by 5 for now. Actually, I'm going to put in x because this is what we're trying to find. We're trying to change that speed. And that is, we want it to be equal to Brandon's, which, okay, cool. They gave us 588.6 is this distance. And it's that distance divided by the sand because he doesn't spend any time on boardwalk. So this is the equation we're solving. You probably did some fraction busters last year, but it's one of the things we're going to revisit at the end of this year too. So there's multiple ways of solving this. The way I would suggest is subtracting at 327.6 from both sides. So we can kind of get that stuff together. So we've got, and again, you should be doing this on pencil paper. I'm just writing it with the calculator so that you can kind of see my steps. So 588.6 minus 327.6 divided by 3, that equals 87, which is kind of nice. So if you remember the rest of it, it was 49 over x equals 87 because x is representing this boardwalk speed. I'm going to write it as 87 over 1 because a lot of times we're better at handling fractions when we have these proportions on both sides or ratios on both sides. So we can solve this by cross multiplying or multiplying both sides by x. So we get 489 equals 87x. Basically, we are flipping. Instead of dividing by x on the left, we are multiplying by x on the right. That keeps our equation balanced. 489 equals 87x. So 489 divided by 87. 5.620689,655. Keeps going. But we're trying to make it uber precise here. Boom. Number of attempts. I was just looking at it. So I wonder if we could even tell a difference if it were like just 5.6 and we're not as precise. Probably not. Oh, it still counted it, I think. But if we were like 5.5, sorry, I'm just curious. We're almost done. Yeah, that looked like Brandon was ahead. So we want to be precise here, at least 5.6. But we will move on. Oh, we are done. I thought that was great. I don't know about you. The only thing that would make that better is if I actually had some tacos. But that is the lesson. That was day 2 for Pythagorean Theorem. I hope that was a little bit fun. That was a little bit of a mix up. Not exactly Pythagorean Theorem heavy, kind of just using math in different real world situations. Hope you enjoyed it. I'll see you later.